Hi, kids. Let's go over how you can decide if an equation, a one variable equation, has one, none, or infinitely many solutions. So the first thing you're going to do is combine your like terms and compare both sides of the equality. Okay, you're going to take a look at your coefficients, and you're going to take a look at your constants. All right. If your coefficients on both sides of the equality are different, whether the constants are the same or different, that doesn't matter. The same, Miss Rose, same. Same or different doesn't matter, because if those coefficients are different, the result is going to be that you will have one solution to your equation, okay? But if your coefficients are the same, bells and whistles and sirens should be going off in your head, because you're either going to have no solutions or infinitely many solutions. So then the deciding factor will be to look at your constants. If your constants are the same, you literally have the same expression on both sides. Literally any solution will work for your variable. So it's said that you have infinitely many solutions. You can plug in any number you can think of for the variable and it will work, okay? But there are some equations that are invalid. They just can't be solved. Sometimes the solution is that there is no solution, okay? So if you take a look at the coefficients and they are the same on both sides after you've simplified, but the constants are different, then you indeed have no solution. Okay, if you need a moment to write that down, here's a good time to pause your video if you didn't have enough time to take your notes and keep up. Okay, but if you're ready, let's go ahead and move on to some examples where we'll make these little rules a little bit more real, okay? So let's take a look at a couple of examples here. And I'm going to go ahead and let me take off some of these answers here. Oops. Spoiler alert. Right? And so we've got three equations here, right? Our first equation says 2x plus 1 equals 3x plus 1. I'm going to take a look at the coefficients first. Are you with me? So let's find the coefficients. And our coefficient on this left side is a 2. Our coefficient on this left side is a 3, different number. So our coefficients are indeed different. Next, I want to take a look at my constants, but really, truthfully, I don't care if they're the same or different, because I know if the coefficients are different, I'm going to have one solution and one solution only. But for the heck of it, let's just take a look. And hey, we have a positive one over here. We have a positive one over here. So our coefficients are indeed the same. But either way, we know that this equation is going to have one solution. Yay. So let's prove it. Let's find the one solution. Why not? So first, we're going to combine our variables. Get our variables together on the same side of the equation. I'm going to subtract 2x from this side and then subtract 2x from that side. That way I end up with a positive leading coefficient. That always makes me happy. So over here, those terms cancel. And what I'm left with is, on the left side is a 1. 3x minus 2x is x plus 1. Now I can get my constants together. I can subtract 1 from this side and subtract 1 from this side. And it looks like x is equal to 0. So I have one solution, and the one solution is nothing, but sometimes 0 is a solution, and in this case it is. Because if I multiply 2 times 0 and add 1 to that, that's 1. 3 times 0 is also 0, and 0 plus 1 is 1. So that checks out. Now, let's take a look at our next equation here. Let's take a look at our coefficients on both sides. Looks like I have a positive 2. So my coefficients are the same. If my coefficients are the same, I'm either going to have one solution, infinitely many solutions, or no solution. So next I'm going to take a look at my constants. And my constants here are the same. And if you read it out loud to yourself, well, it says 2x plus 1 equals 2x plus 1. Well, of course it does. It's just the same expression being repeated. So this is going to have infinitely many solutions. Infinitely many solutions. If you try to solve this, and you can, I mean, you don't have to believe me, you don't have to follow these rules if you don't want to, but let's try to find the solution. Let's subtract 2x from both sides. What's going to happen when we do that? Oh, that's an x, Miss Ra. What's going to happen when we subtract 2x from both sides? That's going to cancel on both sides of the equation, right? And we're going to end up with 1 is equal to 1. That's a true state. Let's say we want to keep going. What if I would subtract 1 from this side of the equation, try to get my constants together? Well, then I would subtract 1 from that side of the equation, and I'd end up with 0 equals 0. Well, does 0 equal 0? Does 1 equal 1? Sure it does. That's a true statement. If you end up with, when you're trying to solve it, you end up with a true statement, it's also a hallmark of that there are infinitely many solutions. If you don't believe me, try plugging in any number. Try doing the substitution for yourself. Just pick a number. I don't even want to pick a number for you. Pick any number that you want to. It can be a decimal, it can be a fraction, it can be a negative integer. And it will work in that equation, I promise you. Okay, but let's take a look at this third equation here at our coefficients. Well, our coefficients this time are the same, right? So our coefficients are the same. What about our constants? Are our constants the same? Well, I have a positive 2 on the left side, and I have a positive 3 on this side. So my constants are different this time. So if my constants are different, but my coefficients are the same, I have no solution. This is an invalid equation. It just doesn't have an answer. It's just not solvable. Okay, so let's think about it this way. Can I ever take a number and double it, add 2 to it, and then take the same number, double it, and add 3 to it this time, and come up with the same value? That would never work, right? I would always have one more on the right side of the equation. It would just never be in balance. So if you don't see it that way right away, no big deal. I can subtract 2x from this side. I can subtract 2x from that side, right? And then my variables on both sides are going to cancel. And what I'm left with here is 2 equals 3. Well, no, it doesn't. That's false, right? I could continue. I could keep trying to solve it. I could subtract 2 from both sides, try to get those constants together, and I would end up with 0 equals 1. Well, no, it doesn't. That's false. If what you end up with here is a false statement, then that's another hallmark of that there is not a good solution to this equation. and you want to double check your work, of course. But so just to recap, if you have if your coefficients on either side of the equation are the same, you'll either have infinitely many or no solutions depending on your constants. But if your coefficients on either side of the equation are different, you will have one solution. Thank you very much, kids. Have a good one. See you in class.